Mainly induction motor is covered in the quiz. Prove mathematically why starting current is high in the induction motor. During starting, induction motor is a short-circuited transformer. During running, EMF induced in rotor reduces to SE2. Rotor reactance reduces to SX2 during running. Hence, rotor current during running is equal to SE2 divided by under root R2 square plus SX2 square. As slip increases, both numerator and denominator increases. However, increase in numerator is much more than denominator. It is due to constant term R2 square in denominator. Hence, starting current is high in induction motor. Explain very briefly why starting torque is low in induction motor. Torque in induction motor is equal to flux into rotor current into rotor power factor. At starting, slip is equal to 1. Power factor of rotor is very low, resulting in reduced starting torque. What is the difference between Pelton wheel, Francis turbine, and Kaplan turbine? Pelton wheel has high head, Francis turbine has medium head, and Kaplan turbine has low head. What is meaning of starting time, permissible starting time, start time hot, and start time cold? Starting time is a time taken by motor to reach full speed from zero speed. Permissible starting time is a time taken by motor to reach limiting temperature after starting. Suppose a motor is running and stops. It fails to start again. Safe start time hot is the time taken to reach limiting temperature. Suppose motor is not running and it fails to start. Start time cold is the time taken by motor to reach a limiting temperature. Start time is calculated for both stator and rotor. Whichever is lower is taken as start time. Starting current of induction motor is high and motor is heated more during starting. Thumb rule is 1 hot start, 2 cold starts, or 3 equally spaced starts in an hour. This rule may not be applicable for fan motor as its starting time is high due to high inertia of fan. In a double cage motor, which cage is kept outside, brass or copper? Cage with brass bars is kept outside and cage with copper bars is kept inside. For convenience sake, let us consider only top and bottom bars. When a three-phase voltage is applied to a three-phase winding, rotating flux is produced. Rotating flux induces current in rotor bars. Induced current produces flux around conductors. There is a large reluctance to flux around outer conductors due to presence of air gap. Hence, flux around outer bars is less. Back EMF in inner bars is more than outer bars due to more flux around them. Hence, current increases in outer bars and decreases in inner bars. Outer bars are made of brass, which has higher resistance. Moreover, outer bars have lesser diameter, which also increases resistance. Starting torque is proportional to rotor resistance and hence increases. Starting current decreases with increase in rotor resistance. During running, frequency of rotor current decreases, reducing back EMF. More current flows in inner bars due to less resistance of copper bars. This results in improved efficiency as I square R loss of rotor decreases. Back EMF is expressed as I2 X2, where I2 is rotor current and X2 is rotor reactance.